Ready for science? Can you talk loud when you talk? Yeah. Does hot air go up or down?
Up.
Good job. Okay, so we're going to talk about how the air moves. Okay? Does that sound good? I'm going to try and cover it fast. Okay? We should do these ones first because otherwise I don't know if they're going to work. So when hot air gets hot, it gets big and expands. Remember, like we talked about last time, when we're hot we go like this. Oh, it's so hot. And we stretch out. And when we get cold we go, oh, and we crunch down and we want to get warm, right? Water and air kind of does the same thing. So when they get hot, they're going to expand and they're going to go up. And when they get cold, they're going to get crunched down and they're going to start going down and sinking. Okay? So we're going to do that with this. Okay? So the first one we're going to do, see if I can do this. So this is hot, that's why it's red, and that one's cold, right? See if I can do it without losing water. There we go. Okay, the hot one is on top. Right. Okay, so when we move this out, what is the hot water going to do? Is it going to stay up or is it going to sink?
Stay up.
It's going to stay up. Good job. Okay, let's watch. Should. Whoa. Yep.
What is red plus blue?
Red plus blue.
Equals?
No, we're losing water.
Equals?
Apparently, these two jars don't want to match up.
What is red plus blue?
Equals purple.
Purple.
Yep. Okay, come sit down. Okay, see? Is the red staying up? I'll put this on here to kind of absorb this. Prepared, huh? Yeah? Is the red staying up? Yes or no? Yeah, it's staying up, huh? It's working. That's what it's supposed to do, so that's good. So, because the hot air goes up, it's going to stay up in the top, right? And as it starts to cool down, it'll start to settle a little bit down here, but not a lot, okay? Next, now we're going to try putting the cold on the bottom and put the hot on the bottom and the cold on the top. Does that sound good? Yeah, we're going to see how this works. Okay. So this one.
Get it out.
You want to help with this one? Since it's cold, it shouldn't be too bad. Ready?
What is blue plus red?
Equals
Purple.
purple.
When you meet this is red and blue.
There
This
we
is
go.
red and blue.
See? And the ice floats up too. Okay, ready? Okay. Gotta get these lined up, make sure they're all nice and straight so we don't lose as much water. But so is the hot water gonna go up or stay down?
Stay down. Up.
It goes up because hot goes up, right? Okay.
This is blue and red.
Blue and red. Okay, and watch when it comes up. So what is supposed to happen, hopefully it does, is the hot is going to start coming up in here and you'll start seeing waves. So watch for the waves, okay? Here we go.
What is blue plus red?
There'll be purple waves.
Equals
Oh, you see the waves? Look at that.
purple.
Whoa! Did it go up? Yeah, the red went up. Look at that.
The red went up.
That's a pretty dramatic difference. Purple. And
Let's try different color.
the blue is coming down, right?
Let's try different color.
You want to try other colors too? Maybe we can later.
Actually, I'm trying to bring in.
Is that pretty cool? Did you see the waves?
Did you see the waves?
Yeah, so
Purple.
So
Wow.
when stuff gets hot, when the air gets hot, it starts to make waves and it starts pushing and pushing.
Brown.
Yep, and it's brown on the bottom, huh? So when the air heats up, it pushes and it pushes, and that's how the air starts making wind, and we can feel the wind going, and we can fly kites on it. We can do all kinds of fun stuff. But that's why the wind is made, because it gets hot. When the sun hits it, it gets hot and it goes and pushes past us. It can make tornadoes and all kinds of crazy stuff too. Is that pretty cool?
Is that pretty cool?
Yeah, I like those. It worked. And then, here, I'm going to move these. If I can. It worked. Okay. So now we can focus on these a little bit. Okay. We've got, so now we're going to talk about the different layers of the air in the atmosphere, okay? Remember what atmosphere is? Atmosphere is way up in the air, all the way down to the very bottom right here against the earth. See? You got the mountains. You see? You got the mountains. And even down in the bottom. Yep. So all of the very first down here where we are at is the troposphere. Okay? Yeah. So we're going to do different layers, okay? You ready? You want to pour the first one in? That was supposed to be purple. That blue is really strong. Let's pour it in. This is our troposphere. Okay, our troposphere is all the air that we breathe. Yep, go ahead. You can pour it. It totally looks black. It's supposed to be purple. Ooh! That's really dark.
Black.
Yep. Okay, so apparently our troposphere is polluted because it's black. Yep. So we've got airplanes, and you've got hot air balloons, and
Troposphere.
and it's all the clouds and everything, and then there's 4 more that are over the top of it. So there's the troposphere. That's where we live, basically, and the birds live too. Next one is stratosphere.
Stratosphere.
Okay, you want to pour the stratosphere in.
What is red plus black equals?
Oh, come on. This is totally not working. We'll see if it evens out. I don't think it is.
Brown.
Yeah, I think all of it's going to end up black. The stratosphere ends up being where the ozone gas is. Ozone gas protects us. It keeps the sun from hitting us. So, and that's up at the very, very top of the stratosphere. And that's why that one's so important. Because that's protecting us from the sun. Otherwise, the sun would burn us. It would hurt really bad. And then there's the mesosphere. The mesosphere burns up comets when they come down. Is that kind of cool? When they hit the mesosphere, they burn up and shrink so that they're not so big. They fall apart. So the thermosphere has also has the ionosphere inside of it, which also gets up to 2,000 degrees Celsius. Super, super hot. That's like crazy hot. And a lot of them go from hot to cold to hot to cold, and they make the waves with all the hot and cold in between them. Okay? Just like we saw in this one over here, it made waves. And it makes the climate as things push around and make the wind. And then the very outside is the exosphere where satellites are. And a lot of the molecules of gases can escape out into outer space in there. So that's very super, super, super thin. Super, super thin. The exosphere is super, super thin. So remember the pictures of the Earth that we saw on the internet? And you can see the atmosphere around the outside of it. It looks like a light going around it. Remember that? So that's what all of this is. That's all of these. Is that kind of cool? Okay. This one didn't really work out. But you get the idea? Is that good?
Is that good?
Okay, we'll call it good then. Okay? Good science. Should we see if we can get these to mix? They're not supposed to mix. They're supposed to stay different colors. It didn't work for me.
Black plus green equals...
More black.
More black
Yep. Plus yellow equals...
equals...
More black.
more black
Plus blue equals... More black.
Oh, more black.
Man,
No.
why does black take everything? Yep. Look at all that black.
Black.
Apparently our pollution has broken through all of the layers of the atmosphere. This is a very serious condition. We have permeated the ozone and the ionosphere.